Let's discuss intercepts. When a straight line intersects the x-axis at a point A and we have the same line intersecting the y-axis at point B, then the line segments OA and OB are referred to as the x-axis and y-axis intercepts respectively. Let's try to understand this graphically. So here we have the coordinate axis, we have the x-axis and the y-axis, and we have the origin O. We're going to consider a line which cuts the x-axis and y-axis. So here the line cuts the x-axis at point A and it cuts the y-axis at point B. Now here OA is going to be referred to as the x-intercept of that particular line, and then we have a length OB, so this is going to be defined as the y-intercept of that same line. Fine. Now the intercepts can be positive or negative. For this particular case, here we see that the line cuts the x-axis, the positive x-axis, and the positive y-axis. So that means the x-intercept and y-intercept are both positive. So we could have other possibilities where the line cuts the negative x-axis and the positive y-axis. In that case, we have a negative x-intercept but a positive y-intercept. Or the other case where the line cuts the negative y-axis and the negative x-axis. So here we have a negative x-intercept and a negative y-intercept. And the other case would be the line cuts the negative y-axis and the positive x-axis, meaning it's going to have a positive x-intercept and a negative y-intercept. Now that we have understood the concept of an intercept, so then what we'll do, we'll try to find out the equation of a line that is parallel to the x-axis. So here we're going to consider the coordinate axis. We have the x-axis and the y-axis intersecting at the origin O. Now what we'll do, we're going to consider a line that is parallel to the x-axis. So here we have a line that is parallel to the x-axis, and as we can see from the diagram, this particular line is going to intersect the y-axis only. No matter how we stretch from on the left hand side or on the right hand side, it's never going to intersect the x-axis, meaning it's only going to have a y-intercept. There will be no x-intercept. Let us suppose that this line intersects the y-axis at a particular point with coordinates given by 0, b. So that means it's a point, if we call it A, then the point A is at a distance of b units from the origin O. Our goal will be to obtain the equation of this particular line. So there are several ways to define the equation of this particular line. So let's say we use the tabular method. So here what we'll do, we'll take a grid, a table. Now in this particular table, we're going to divide it into two sections. The first one is going to be X and the bottom section is going to be Y. Okay. So let's say if we take the value of X as 0, so what's the corresponding value of Y going to be? The corresponding value of Y is going to be B. Let's say if we take the value of X as 1, so here we have 1, then the corresponding value of Y, it's still going to be B. And then if we consider X to be -1, we are also again going to get B. So no matter what values of X we choose, we are always getting the value of Y as equals to B. So from this particular table, we can say that the equation of the line is going to be Y equals to B. So this is the tabular method from which we can find out the equation of the line, which is parallel to the x-axis, and it's given by Y equals to B. Now, if we choose another way, so let's say this A point also corresponds to another point P, which has the coordinate h, k. So that's the locus of a particular point P. Now, if we find out the distance OP, the OP distance, that's simply equals to the y-intercept, so that's equals to B. Now, we can use the distance formula to find out the length of OP, because here we have the coordinates of point O as well as coordinates of point P. O, that being the origin, its coordinates are 0, 0. So if we use the distance formula, so here we have square root of, so we take the difference of the x coordinate, so that's h minus 0 squared, added to the difference of the y coordinate squared, so that's k minus 0 squared. This is equals to B. Fine. So here we have square root of h squared plus k squared equals to 0. But at P, at that particular point P, clearly the value of h is 0, which means that we have square root of k squared equals to, this is B, equals to B, meaning the value of k equals to B. Now, to find out the equation of the locus, all we have to do is replace the value of k with y, and that gives us the equation y equals to B. So that's the locus, that's the equation of the locus of that particular point P. Now here also we are getting the same value, y equals to b. So that means a line that is parallel to the x-axis is going to be given by this particular equation, y equals to b, where b is here, it can be any constant. So here b is the y-intercept. So what about if b value equals to 0? So if we have b equals to 0, so that simply means that y equals to 0, and this is the equation of the x-axis. That's the equation of the x-axis. All we have done is taken b equals to 0. That means it is cutting the line is intersecting the y-axis at the origin. That's what it. A side note, here I have chosen b as the y-intercept of the line. That means in the equation y equals to b, b is the y-intercept. However, b is simply a constant. We can replace b with any other alphabet. For example, in the problems that we'll be solving subsequently, I will be using the letter A instead of letter B, but it will mean exactly the same thing. Okay, now that we have worked the equation of a line parallel to the x-axis, we'll discuss the equation of a line parallel to the y-axis. So in order to obtain the equation of a line parallel to the y-axis, let us consider a line L, and the line L is parallel to the y-axis. It's also perpendicular to the x-axis. We'll come to that in a moment. Now this particular line L, it has only got an x-intercept. Here, if we extend the line at both ends, we can observe that it's never going to meet the y-axis. It's always going to be parallel to the y-axis, which means that it's only going to have an x-intercept. So this is the x-intercept with the value equals to a. Now, in order to find out the equation of this line, what we'll do, we'll consider a point. Let's call it point P, having the coordinates h, k. So this is the locus of that particular point P. And here OP, that will be simply equals to the x-intercept value, which is equals to a. We can use the distance formula to find out the length of OP. So that's going to be h squared plus k squared equals to a. Now here, the value of k, that will be equals to 0, because on the x-axis, the k value is going to be 0. So which gives us h equals to a. Now to find out the equation of the locus, all we have to do is replace the value of h with x, and that gives us x equals to a. So this is going to be the equation of the line. Now, or if we want to use the tabular method, what we can do, we can take a table, and here we have the x values and the corresponding y values. So here, for any values of y that we take, so let's take y equals to 0. So if we take y equals to 0, the corresponding x value, that's going to be a. If we take y to be -1, so here y value is -1, so that's below the origin. So for this y value equals to -1, the corresponding x value, that still equals to a. And for all positive values of y, so let's say y equals to 2, we also going to get, so this is 2. So for this particular value of y equals to 2, we're still going to get x equals to a. So this tells us that the equation of that line must be x equals to a. So this is how we can find out the equation of a line that's parallel to the x-axis. If we talk about the very special case, when the value of a is 0. If the value of a is equals to 0, so that means the x-intercept is 0. X-intercept is 0 means that this particular line L is actually lying on the y-axis. So that gives us the equation of the y-axis. So the equation of the y-axis is simply x equals to, so we're going to replace the value of a with 0, x equals to 0. Fine. Let's apply all of these ideas to solve few problems. We need to find out the equation of a line that is at a distance of 3 units below the x-axis and is also parallel to the x-axis. So here we have the Cartesian coordinate system. We have the x-axis and the y-axis meeting at O, and we also have a line L, and this particular line L, it's 3 units below the x-axis. So this is 3 units below the x-axis, and it is parallel to the x-axis. So we know that the equation of a line that's parallel to the x-axis is given by y equals to a. Now in the previous case, when we were trying to derive the equation of the line that's parallel to the x-axis, we use y equals to a. So where a was the y-intercept. So here a is the y-intercept. To find out the y-intercept, we'll consider the coordinates 0, -3. This is the point where the line L intersects with the y-axis, and that's going to help us find out the y-intercept. Now clearly this line is 3 units below the x-axis, so that means its y-intercept value, which is given by a, that's going to be equals to 3 units. Hence a will be equals to -3, which means that y will be equals to -3, and that's going to be the required equation of the line. So that's the equation of the line. Okay, let's go to the next problem. Problem number 2. We need to find out the equation of a line which is parallel to the y-axis and it's at a distance of 5 units to the left of the y-axis. So clearly we have a line which is 5 units to the left of the y-axis. This is going to be a particular line. Because the line L lies 5 units to the left of the y-axis, so it's only going to have an x-intercept with a value of -5. Now we know that the equation of a line parallel to the y-axis is given by x equals to a. Now in our case here, a value that's equals to -5. So thus we have the equation of the line given by x equals to -5. Okay, let's go to the next problem. Problem number 3. We need to find out the equation of the line that is parallel to the x-axis and is going to pass through the point 3, -5. So 3, -5 means we go 3 units along the positive direction of x-axis and then 5 units below the x-axis. So let's say the point 3, -5 lies somewhere here. Let's name it as point number A. Now we're going to draw a line passing through this particular point A in such a fashion that it is parallel to the x-axis. Okay, so this is the line which passes through the point A, 3, -5, and it's parallel to the x-axis. Our goal will be to determine the equation of this line. Now we know that whenever we have a line which is parallel to the x-axis, its equation is given by y equals to a. Now our goal will be to obtain the value of a. Now a is nothing but the distance of the line from the x-axis. So the distance, which is actually the y coordinate value, so this distance is nothing but 5 units. Now since this is 5 units below the x-axis, so here we'll have to consider the value of a to be equals to -5. So that means equation of the line passing through the points a, 3, -5, it's going to be y equals to -5. Okay, let's go to the next problem. Find the equation of the line that is parallel to the y-axis and it passes through the point -4, 3. So let's try to plot the point -4, 3 first. Here is the point A with the coordinates -4, 3. Now we're going to draw a line which passes through this particular point in such a fashion that it is parallel to the y-axis. So let's say this is the line passing through the point A, -4, 3. Our goal will be to determine the equation of this particular line. Now we know that any line which is parallel to the y-axis has the equation given by x equals to a. Fine. Now our goal will be to determine the value of a. A is nothing but the x-intercept here. So what's the x-intercept? So the x-intercept value, that's -4. So since x-intercept is -4, so we have a equals to -4, which implies the value of x is going to be equals to -4. So this is going to be the equation of the line which is parallel to the y-axis and it is passing through the point -4, 3. Let's go to the next problem. Problem number 5. We need to obtain the equation of a line which is equidistant from these two lines. One is x equals to -4 and one is x equals to 8. So our goal will be to first sketch the graph of the line x equals to -4 and x equals to 8. So that means whenever we have the equation of a line given by x equals to -4, this is a line which is going to be parallel to the y-axis. Fine. And having an x-intercept of -4. So that means x-intercept of -4. That means let's say this particular point is at a distance of 4 units from the origin. The negative sign simply indicates that we are on the negative x-axis. So we are going to draw a line which passes through this particular point and parallel to the y-axis. We have the line which is parallel to the y-axis and it has a x-intercept of -4. So that means this particular line has the equation x equals to -4. Then we have the other line x equals to 8. So x equals to 8, that particular line is also a line that is parallel to the y-axis. So since it's parallel to the y-axis, now we'll have to check what's the x-intercept is going to be. So its x-intercept is going to be 8 units. So that means, let's say this is the value corresponding to x equals to 8. So we'll draw another line passing through this particular point, which is going to be 8 units from the origin. So we have the line given by the equation x equals to 8. So it has a positive intercept of 8 units. Our goal will be to determine a line which is equidistant from both the two lines. Now it only makes sense that that line also has to be parallel to the y-axis. Only then we can say it's going to be equidistant from both the two lines, x equals to -4 and x equals to 8. Now the goal will be to find out what will be the equation of that particular line. Since the line is going to lie between these two lines, x equals to -4 and x equals to 8, our goal will be to first determine the x-intercept of the new line. So that is going to be half of -4 and 8, which means we have 8 minus 4, so that's going to be 4, and this corresponds to 2. So that means it's going to be 2 units from the origin. So if it's 2 units from the origin, so this is the point through which the line is going to pass. So let's draw that line. As evident from the diagram, the particular line is at a distance of 2 units, positive 2 units from the origin. So that means the equation will be given by x equals to 2. So this is the line x equals to 2, which is equidistant from both the two lines, x equals to -4 and x equals to 8. Let's go to the next problem. Problem number 6. We need to find out the equation of a line that is perpendicular to the x-axis and it has an intercept of -2 on the x-axis. Meaning, we consider a point which is -2 units from the origin, or you can say 2 units lying to the left of the origin, and we have a line which is perpendicular to the x-axis. So let's draw that line. So here we have the line L, which is perpendicular to the x-axis, and it is going to have an x-intercept of -2. Our goal will be to determine the equation of this line. Now we know that whenever we have a line that is parallel to the y-axis, its equation is given by x equals to a, where the value of a is provided to us. That's nothing but the x-intercept that has a value of -2, which means that the equation of the line is going to be x equals to -2. Let's go to the next problem. Problem number 7. We need to find out the equation of the line that is parallel to the x-axis and having an intercept of -2 on the y-axis. That's a very simple problem. Again, we know that in any line which is parallel to the x-axis has the equation given by y equals to a, where a is the y-intercept. Now it's given here that the value of a is the y-intercept value is -2. So this implies that y will be equals to -2. And if we sketch the graph of that particular line, so this is going to be the line which is parallel to the x-axis. Its equation is y equals to -2, meaning it has a y-intercept of -2. Let's go to the next problem. Find the equations of the lines passing through the point 4, 3 and are respectively parallel and perpendicular to the x-axis. So that means we have to find out the equation of two lines. One of the line is going to be parallel to the x-axis and the other line will be perpendicular to the x-axis. And in both the two cases, the lines are going to pass through the point 4, 3. So let us suppose that we have a particular point A with the coordinates 4, 3. So let's begin by first obtaining the equation of the line that passes through the point A and is parallel to the x-axis. Now we know that any line which is parallel to the x-axis, its equation is given by y equals to a. Fine, where a represents the y-intercept. Now to find out the y-intercept, we only have to check at what point this point is cutting, or at what point the line is cutting the y-axis. So this distance is nothing but the y coordinate of a, which is 3 units. So that means we have the value of a equals to 3, which implies that the equation of that particular line is going to be y equals to 3. Okay, next what we'll do, we'll consider another line which is now passing through the same point A but perpendicular to the x-axis. So here we have the line which is perpendicular to the x-axis. If it is perpendicular to the x-axis, it also means that it is parallel to the y-axis. Now what's the equation of a line that's parallel to the y-axis? Now we know that that equation of that line will be given by x equals to a, where a is the x-intercept of that line. Now to find out the x-intercept, all you have to do is find out that the point at which the line cuts the x-axis, cuts its line segment. That means its distance from the origin O. So that's nothing but 4 units. So that means we have the value of A here equals to 4, or we can simply say that the equation will be x equals to 4. So that's going to be the equation of that particular line, which is perpendicular to the x-axis and passes through 4, 3. Let's go to the next problem. Find the equation of the line that is equidistant from the lines x equals to -2 and x equals to 6. This is a problem that's quite similar to problem number 5. So let's do that. So let's start with the line x equals to -2. So x equals to -2 is a line which is going to be parallel to the y-axis. This is parallel to the y-axis and has x-intercept of -2. And for the other line given by x equals to 6, so that is a line which is also going to be parallel to the y-axis with an x-intercept of +6. Fine. Okay, so let's sketch the two lines. So here we have two lines. The line which is represented by the yellow color, so that line is parallel to the y-axis and it has an x-intercept of 6 units. So its equation is given by x equals to 6. The other line, which is represented by the blue color, has an x-intercept of -2 and parallel to the y-axis. So its equation is x equals to -2. Now we need to find out a line which is going to be equidistant from both the two lines, and clearly that line is also going to be parallel to the y-axis. So it's going to lie somewhere between the two lines. So let's say this is the line and we need to find out this equation. So we need to find this x-intercept. So its x-intercept will be the average of the x-intercept of both of the two lines. So that means we have the x-intercept that's going to be equals to half of the sum of the two values. So we have some -2, that's the x-intercept of the line x equals to -2. This will be added to the x-intercept of the other line, which is 6. So that means we have 4/2, which is equals to 2, and therefore the equation of that line is going to be x equals to 2. So this is the equation of the line. This is the line which is parallel to the y-axis and it has a x-intercept of 2 units. And this particular line is going to be equidistant from x equals to -2 and x equals to +6. Let's go to the next problem. So find the equation of the line that is equidistant from the lines y equals to -2 and y equals to 10. So let's start with the first equation. We have here y equals to -2. Now this is a line that is parallel to the x-axis with a y-intercept of -2. So let's draw a line which is parallel to the x-axis and has a y-intercept of -2. So y-intercept of -2, that means it's going to intersect the y-axis at y equals to -2. So here we have the line y equals to -2. Next, if we consider the other line y equals to 10, so this is a line which is also parallel to the x-axis with an x-intercept of with a y-intercept of +10. Okay, so let's sketch that particular line. So here we have the line which equation will be y equals to 10. That is parallel to the x-axis and it has a y-intercept of +10. Meaning it intersects the y-axis at y equals to 10. Okay, now that we have the two lines, we have to find out the line which is equidistant from both the two lines. Now it's clear that that line has to be also parallel to the x-axis. Only then it can be equidistant from both the two lines. Now to find out its y-intercept, so y-intercept of the new line, y-intercept that will be equals to the average of the intercept of the other two lines. So we have half times -2 added to 10. So 10 minus 2, that's 8. 8/2, that's going to be 4. So that means the equation of the line is going to be y equals to 4. So this is the line that's going to be parallel to the x-axis and it's going to have a y-intercept of +4. So y-intercept of +4, so that means it's going to pass through the point y equals to 4. So this is going to be the line y equals to 4 and it's going to be equidistant from both the two lines, one given by y equals to 10 and other given by y equals to -2. Okay, so let's do one more problem. That will be the final problem of this particular lecture. Problem number 11. What are the coordinates of the vertices of a square formed by joining the four lines given by x equals -4, x equals to 2, y equals to -2 and y equals to 3. So let's start by first sketching the line x equals to -3. So x equals to -3, that's a line which is going to be parallel to the y-axis with a x-intercept of -3. So x-intercept of -3 means, let's say, the line is going to pass through this point x equals to -3. Then we consider the next line x equals to 2. So this line is also going to be parallel to the y-axis, but it's going to have an x-intercept of 2 units, meaning it's going to pass through the point x equals to 2. Now we will sketch the line given by y equals to -2. So y equals to -2 corresponds to a line which is parallel to the x-axis and has an y-intercept of -2. Y-intercept of -2 means it is going to pass through the point y equals to -2. Okay, so let's sketch that line as well. So here we have the line y equals to -2. This was the line x equals to +2, and we have x equals to -3. And finally, we're going to sketch the graph of the line given by y equals to 3. So here y equals to 3 is a line that's parallel to the x-axis, and it has a y-intercept of 3. So this is the point through which, this is the point corresponding to y equals to 3. It's going to pass through this point. So we get the line with the equation y equals to 3. Now what we see here, that we have a square that is formed. So this square, let's say, has the vertices given by a, b, c and t. Our goal will be to determine the coordinates of the vertex a, b, c and t. Now clearly the point a, it's the point where the line y equals to 3 and x equals to -3 intersect. So that means coordinate of that particular point is going to be -3, +3. Fine. Coming to point B. Point B is the intersection of the line y equals to 3 and x equals to 2. So that means its coordinates are going to be, we'll have the x coordinate having a value equals to 2 and the y coordinate will be +3. Coming to point C. C is the intersection of the line x equals to 2, this is x equals to 2, and the line y equals to -2. So that means the coordinates are going to be 2, -2. And finally, we have the point D, which is the fourth vertex of the square. This is the intersection of the line x equals to -3 and y equals to -2. So that means the coordinates of point D are going to be -3, -2. So this is how we can use the intercept form to find out the coordinates of the vertex of the particular square, which is formed by the lines x equals -3, x equals to 2, y equals to -2 and y equals to 3. So this is the end of the lecture. So here today we have discussed about the intercepts of a line.